Okay, so we've all seen those incredible AI demos, right? The ones that just seem to do the impossible. But have you ever stopped to think about what it really takes to get from that flash of brilliance to a solid, reliable product that you can actually use every day? Well, it's a huge leap. And today, we're going to pull back the curtain and look at all the complex engineering that goes into making that happen.
And look, when a pioneer like Andrew Ng says this stuff is complex and needs a good explanation, you know it's important. He's pointing to this massive shift happening in the entire industry. It's not just about the AI model anymore. Nope. It's all about the engineering, the nuts and bolts that turns a cool algorithm into something you can actually count on in the real world.
So here's our game plan. First, we'll dive into that AI engineering gap. Then, we'll check out the essential building blocks you need. After that, we tackle what might be the hardest part of all, evaluation. Then we'll get into MLOps, which is like the AI factory. And finally, we'll take a peek into the future. All right, first up, let's really dig into this idea of the AI engineering gap. And I want to be clear, this is not a small hop. It is a massive, massive chasm that separates a cool demo that works on someone's laptop from a real product that thousands, maybe millions of people can depend on every single day.
You know, a demo can feel like a magic trick. It's awesome, but it can also be super unpredictable. You ask it the same question twice, you might get two totally different answers. A real product just can't do that. It has to be reliable, it has to be scalable, and it needs to be monitored all the time to make sure you're getting a consistent experience. You know that weird, jarring moment when a chatbot calls you by a different name? Yeah, that's exactly the kind of stuff that good engineering is supposed to prevent.
So, to get across that gap, engineers are staring down three huge hurdles. First is that inconsistency we just talked about. Second, you have hallucinations. You know, when the model just confidently makes stuff up. There's this really fascinating theory that the model gets confused between its training data and its own words, almost like a kind of self-delusion. And then there's the third one, and maybe the biggest challenge of all, evaluation. How in the world do you even know if a thing you've built is actually any good?
Okay, so if those are the problems, how do we actually solve them? Well, let's pop open the AI toolbox and look at the essential tools engineers use to start building these applications.
Okay, so at the very heart of how an AI understands language, there's this thing called an embedding. It's basically a process that takes words and sentences and turns them into a list of numbers, a vector. But here's the cool part. That list of numbers actually captures the meaning of the text. This is what lets an AI figure out that mathematically the distance between king and queen is the same as the distance between man and woman. It's literally how meaning gets turned into math.
Now this leads us to two super powerful techniques for making a model better: RAG and fine-tuning. And there's a really simple way to remember the difference. If your model needs new knowledge, say the latest specs for your company's products, you use RAG. You're giving it facts. But if you need to change its behavior, maybe you want it to always answer in rhyme or adopt a very specific personality, that's when you use fine-tuning. So just remember, RAG is for facts, fine-tuning is for form.
And that brings us to what a lot of experts will tell you is the single biggest, hairiest problem in building AI today: evaluation. Seriously, on some projects, just figuring out how to measure if you're succeeding can eat up most of the team's time. It all boils down to that one simple question. How do you actually know if the thing is any good?
I mean, that's the million-dollar question, isn't it? Because without a really systematic way to evaluate, teams are basically just flying blind. They're guessing, they're going on, oh, it seems okay, or just looking at a few examples here and there. That's so risky, and it just grinds progress to a halt. So how do we get out of that guessing game and actually know if we're building the right thing?
Well, one really powerful method that's emerging is using an AI as a judge. Basically, you get a really powerful model, like a GPT-4, to grade the answers your own application gives. And to do it right, you have to give it a clear rubric, just like a teacher would use. For example, a tool like MLflow might have a metric for faithfulness. Is the answer actually based on the information it was given? If it gets a score of 1, that means the output is pure fiction, completely made up. That's a huge red flag, and it's how you can start to automate this whole process.
But, and this is really interesting, using an AI as a judge comes with its own weird quirks. You know how we humans have recency bias? We tend to like the last thing we saw? Well, AIs often have the opposite problem, first position bias. They're more likely to prefer the first option in a list. And they can also be suckers for long, wordy answers, even if they're wrong. So you have to understand these different biases if you want to build an evaluation system that's actually fair.
Okay, so once you know how to build a model and you have a way to evaluate it, how do you do that reliably? And not just once, but over and over again? Well, that's where MLOps comes into the picture. Think of MLOps as the engineering discipline that builds the automated factory for churning out and maintaining your AI. And the heart of that factory is this thing called an automated pipeline, or CI/CD. The best way to picture it is like an assembly line for software. A developer pushes some new code, that automatically kicks off a whole bunch of tests. If all the tests pass, the entire thing gets neatly packaged up and sent out to users. And the best part? It can all happen without a single human needing to click a button.
And that neat little package, that's usually what we call a container. It's all built around this incredibly powerful idea: build once, run many. A container basically shrink wraps the AI model, all the code and everything it depends on, into one single bundle. This is what solves that age-old developer problem of, well, it works on my machine. It guarantees that the system will run exactly the same, whether it's on a laptop or in the cloud. It is the absolute key to consistency.
So, let's start to pull all of this together. To really build great AI applications now and in the future, it takes a fundamental shift in how we think. We have to move away from just chasing the biggest, most powerful model out there. Instead, we have to become obsessed with the entire product. So if you take away just a few things from all this, let it be these. First, an AI model is just the engine. It's an amazing, powerful engine, but it is not the car. To build the whole car, a real product, you need that rigorous engineering we talked about. Second, evaluation is what tells you if you're even building the right thing in the first place. And finally, MLOps is what helps you build that thing the right way, reliably and repeatedly.
And this leaves us with one last, really provocative thought to chew on. You see, pretty much all the engineering we've talked about today is designed to make AI follow our instructions perfectly. But the next frontier is already here. AI agents that can think, plan, and act on their own to get something done. So the big question is, what happens when the thing we engineered to answer our questions starts asking its own? That's a question that's going to define the entire next chapter of AI.